So Eric, first of all, really thank you so much. It's really an honor for us to have you with us today. I think you don't need any kind of introduction because I think you're one of the most well-known and respected experts in the industrial security community. Maybe just to get us started, can you share some of the most memorable moments of your career?
Yeah, sure. And it's a pleasure to be here, by the way, too. It's been an interesting career. Probably, I'd say the first most memorable moment was way back in the beginning, back in, I think it was 1996, when I was working on a control system, on a network for a control system. And we realized that the problems that this company was having was due to hacking. I mean, that was just revolutionary. And that somebody, and it turned out to be an employee, had hacked into this control system and done a lot of stupid things. It just was inconceivable that somebody would hack a control system back then. So I think that was one of the first really exciting moments. And then I'd say another one was not long after 9/11, when we first started doing tests at the British Columbia Institute of Technology for one of the oil companies on could you hack a PLC. And at the time, I thought, no, they're not. And I remember my guys in the lab coming in and saying, Eric, the PLC is hard faulted. And I told them, no, you made a mistake. You don't understand. And sure enough, so I think those were my really exciting early days. And then since then, it's been a mixture of surprises in a bad way and like those, and surprises in a good way, like how well the Tofino firewall worked out and how much that got used. And the fact that 10 years after, we really launched that, it's still such an important part of the marketplace. So those are sort of the highlights for me.
How did you get the idea?
It started out because we were doing research for the UK government at the time, just again, shortly after 9/11. And one of the projects was to look and see how you should configure firewalls for industrial control systems. I mean, nobody did it at the time. Industrial control systems were just connected to the corporate network. So who would think to put a firewall in? And they were quite far-seeing, and they had asked my lab team to start looking into the right way to configure a firewall. And we did a lot of research, and we learned a couple of things at the time. One of them was that it was hard. In fact, you couldn't properly secure a protocol like Modbus or Ethernet IP or the Siemens protocols or any of the protocols out there using a traditional firewall, because you needed full stack 7-layer filtering, and that just wasn't available. And the second thing we realized is that no normal control engineer, in fact, few even security specialists at the time could possibly configure them correctly. We had very, very senior people from Cisco helping us on the project, and it was hard work. And we thought, like, man. So we realized that we needed to make a firewall that did a couple of things. One, it had to be industrial hardened. That was a no-brainer. Two, it had to be small, because you're not wanting a firewall that is, rack mount. It's going to have to fit into an MCC cabinet or a PLC cabinet. But most important, it had to be absolutely usable by the controls engineers and the field technicians, and even just the electricians who were going to be wiring it in. It had to be accessible. If you didn't do that, all you'd have is configuration mistakes and frustration.
Is there an affordable way, from your point of view, for mid-sized businesses to manage supply chain risk?
Yeah, I think there is. I mean, if they're, let's go for the operators and the asset owners and the people running facilities. First of all, they need to depend on their suppliers to give them good information. They're not, if you're a small operator, you're not going to be able to, completely roll your own supply chain analysis from top to bottom. You need to go and ask for things like a software bill of materials from your primary supplier, and you need to get support from them. The other thing is don't try and do it manually. I mean, it's just too complicated. You will tie up unbelievable engineering resources, for example, doing manual vulnerability hunting for components. So you really want to automate that process. And this applies whether you're a big company or a little company. The complexity of trying to hunt for vulnerabilities, and particularly important, prioritize vulnerabilities, is astounding. And that really needs machine learning techniques and artificial intelligence techniques to sort of find the needles in the haystack, and then a human at the end just to look at the needle and say, yeah, this one's a dangerous needle and this isn't a dangerous needle.
What other kind of developments in cybersecurity do you find especially interesting?
Whole concept of zero trust networks. So there's always been that inherent trust that anybody who managed to get on the network is well-intended. Obviously, that didn't work. That didn't work for the internet, and it hasn't worked on control systems. If you can make your way as an attacker onto, say, one of the lower levels of the network, layer 2 or layer 3, and have the equivalent of a programming terminal or a real programming terminal, or take over a programming terminal, you have absolute free reign to make any changes you want. It's just crunchy on the outside, soft and chewy in the middle. So the thing that I've really been stressing for about the last 2 decades, I guess, and it's starting to really take traction, is, wait a second, why does the operator station over there need full programming capabilities on that controller over there? I mean, does it even talk? Should it even be talking to that controller? But if it should, it should be getting data. It should not be sending programming commands. And so, and how do you prove those two devices? How do you identify and prove those two devices? Passwords are a train wreck, as we all know, personally and professionally. So we need far better ways of cryptographically identifying devices, and then saying this device can talk to this device and do the following things.
Will be interesting to see how it works out, right? Most of the companies that we know today, they are very far away from a zero trust architecture in OT. Right? So, Eric, can you maybe tell us about a case, of course, without naming names, of a business, maybe a medium-sized business that was attacked, where better OT security would actually have prevented or at least mitigated the attack?
The easy case is the old water district, which is a tiny little water district in Florida. And, I really feel sorry for those guys, because they're not, I'm sure the guys on those teams were not security guys. They were people trying to do a good job with limited resources. And they did not know how to set up remote access. I'm sure they were trying to use remote access because they were understaffed and people were trying to serve the community and keep the water system 7/24 by working from home. After the shift ended, something went wrong. So that's a really good example of, they really needed better coaching on how to set up a secure remote access system. Clearly, they had not been introduced to things like two-factor authentication, which aren't difficult to set up. So, really, really sort of basics like that.
Maybe some non-obvious security controls you often see missing, right? And because you see so many clients, and but that you think could be recommended in general or in most cases.
This isn't an OT problem. This is just everywhere. Lack of good password management systems. Everybody runs into that problem, or just about everyone runs into that problem, where IT has triggered some control, like you must reset your password every 30 days. And everybody just goes and adds a number to the back of the password and moves on. I mean, I did it. And everybody ends up reusing their passwords. I'll use that password for 27 different accounts. That is the worst possible solution. Every password needs to be unique. So, in our company and all the companies that I've worked with, I'm saying one of the first things you want to do is people need to remember one good password and have the system remember everything else. That, to me, good password management is critical.
What is maybe another half-truth or a wrong statement which you still encounter often in ICS security or IoT security?
Oh, my absolute favorite one is we've got an air gap. I mean, air gaps are like unicorns. I hear they're out there, but I'm still looking for one. There was some really good testimony a few years ago to the U.S. Congress. I'm trying to remember who it was who gave the testimony. But it was a senior person in the Department of Homeland Security. And he said, on average, they see 17 pathways into a control system. So you go and cut one, you got 16 left. And that's been my experience too. And what you end up doing is you force people to use a USB key. You have to, there's no way you can completely run an isolated control system. Because, you want to make, you've got to get recipe information into the plant floor, or you've got to make changes. You want to make some changes to the PLC. So you're going to be bringing in that laptop. You need to do firmware upgrades or software upgrades. The bits and the bytes that are evil don't care whether it went over a network or a USB key or on the hard drive of a laptop. If you've got bits and bytes moving, no matter how you're moving it onto the plant floor, you no longer have an air gap. So I absolutely do not believe there are air gaps.
And maybe in terms of, supply chain risk or so, are there any half-truths or wrong statements or so?
First of all, one of the half-truths that I think is out there is we don't use any open source software. Everybody uses open source software. Second, we're only worried about open source software. No, you should be worried about all your software. Open source is an issue, there's no question, but proprietary and closed source has just as many vulnerabilities, just as many issues. You need to handle both in exactly the same manner. In fact, open source is somewhat easier. There's more tools for analyzing open source software because, hey, you got source code. Closed source is a tougher problem. It's where actually we spend probably 80% of our time doing closed source analysis. But there's absolutely no evidence that open source and closed source have differences in vulnerability count or in issues or supply chain issues. It's software. And, in some respects, open source can be better because there's more people looking at it.
To wrap it up, Eric, if you could send an email to all CIOs of the world, what would be the core message?
The thing that I would say to them is that, you want to be part of a community. The bad guys actually have a pretty good community for sharing information. So you really, really need to work in a community. Don't try and do this all on your own. So my first message is, start being part of the community, start working on information sharing, getting more information from your vendors, more information from your colleagues, more information from organizations that specialize in this. So that's the first thing is there are solutions out there, but we've got to do this together because the bad guys are working together. And then the second thing is you really, really need to figure out how to use or use tools with artificial intelligence and machine learning. The problem has become too complex. There's, as I mentioned earlier, a software package is no longer a software package. It's 1,000 components on average. I think we see about 1,000 components. There is no way humans can handle that. So like it or not, we built a really complex system. We need to use machine learning tools. We need to use AI tools, and then have the humans check the results.
Thank you so much again, Eric. And of course, we wish you and your team all the best also going forward.
Thank you very much. Same to you. And to everybody out there, good luck.